Alright class, welcome to the video for week 13, day 1. Today we'll be doing profit maximization for firms who are in perfect competition and firms in monopoly. And last few weeks we've been doing what is the firm's optimal way to produce a certain level of output, a certain queue. And now we need to get beyond what the optimal input mix is and go to what is the optimal output, like what queue should we be producing. And so that's what we're going to do in this short set of slides. And so the reading is pages 243 to 252 and 358 to 363. This is perfect competition, and this is a little bit of monopoly. And so what we need to understand is how firms behave when the typical perfect competition assumptions, like many sellers, is violated. And so this is important because a lot of markets today don't have a relatively large number of sellers. And so how are these firms behaving? And so we'll be working on the most extreme opposite case of many sellers, which is just one seller, mono, one seller, monopoly. We've all played Monopoly, come on. And so I want to talk for a moment about profit maximization. What do businesses do? They're trying to maximize their profits. So they're trying to make a lot of stuff and sell it, and spending as little as possible. And so we know the profit equation is total revenue minus total costs. And profit is the quantity you sell times the price you sell it at, minus the quantity you make times the cost it takes to make it. And businesses are choosing the Q, they're not choosing the P or the C, technically. And so what is the optimal quantity? How much? And so we have this nice rule here, which is you should increase quantity if the money you make from producing another unit is larger than the cost of producing that next unit. And so these are our classic marginal benefit greater than marginal cost. And we know that optimal is to keep producing until marginal revenue equals marginal cost. Marginal benefit is equal to the marginal cost. And so I've encoded those into these two graphs that I've made here. And this first graph on the top shows quantity on the x-axis and price on the y-axis. And the orange line is this total revenue line. And you can see here that when total, or the orange line is total cost, and the blue line is total revenue. And so when you see this total cost greater than total revenue, this Q times C is greater than this Q times P, profit is negative, and that's this red, and that's bad. We don't like profits because, or we don't like losses. And so when it's green, this is when total revenue, this blue line, is greater than the total costs. And we see this total revenue as linear here because this firm is in perfect competition. And so each unit they sell for the exact same amount, no matter how much they sell, because there's a lot of sellers in the market. And so profits are maximized where the total revenue is the largest. The difference between total revenue and total cost is the largest, which is here at this 6. And what we can see here is this is the same graph for this firm portrayed here. The difference is that we're plotting, instead of the total cost and the total revenue, we're plotting the marginal cost and the marginal revenue. And so that's why this marginal revenue is flat, because each unit sells for 4. And so the additional money you make from each unit is 4. And so in the first one, you make 4. It only costs you 3, so this is a good unit to produce this first unit. And then the second unit, it costs like 2, and you get 4, so you produce that. This third unit, you get around, it cost you less than 2, and you make 4, so yeah, I'll produce that one. And then here at this 5th unit, you make 4, but it costs over 2. And then the 6th unit, it costs 4, and it brings you $4. Like, sure, I'll make that one. And then if you were to make the 7th unit, it would cost you like 5, but you'd only get 4. And so then the space between total revenue and total cost would start decreasing, the profits would start going down, and that's bad because we want to maximize our profits as a firm, and so you should stop at 6. And so this is kind of digging a little bit deeper into those last two figures I showed you, and this is perfect competition and profit maximization. So this is our typical supply and demand that we've seen. The equilibrium price is 4. What does that mean for a small farmer? Well, Farmer Eldon here, that means that he's got to take this market price. He has no power to move the market price because he's small relative to the total number of sellers in the market. And so they're not affecting this market price. And this is a good approximation for several markets, and a really obvious one is international agricultural market, because there's a lot of sellers and they all have the same product. A potato is a potato. And so this price equals a marginal revenue equals this demand curve. So this is the firm's demand, the firm's marginal revenue, and the price. And so it's all equal in perfect competition. That's fine. It's their baseline model. But what happens when if this individual firm is like the only one there? Well, then something interesting happens. So in this case, this is the demand curve, these Q's and P's, and this marginal revenue curve is not equal to the demand curve anymore. Why is that? It's because the quantity decisions of monopolies affect the market price. If they're the only seller and they produce more, the price decreases because there's just more out there. But there wouldn't be that much more out there if there are a lot of sellers. And so this is why this marginal revenue curve does not equal the demand. So Ben, what do? This marginal revenue is falling faster than demand due to the increase in output, reducing the price they receive per unit. What do? What is their profit maximization decision? What Q should they produce? Well, this is the same graph with a lot more machinery in it. So we've got the demand and the marginal revenue here. And now, because we want to talk about optimal quantity to produce, we need to bring in marginal cost. And so just like perfect competition, monopolists produce where marginal revenue equals marginal cost, so that they don't make different decision rules. It's the same. What is different is that the demand curve is not equal to the marginal revenue curve anymore. And so the optimal quantity to produce is where marginal revenue crosses marginal cost, which is this point here in step 1, and then they charge R, because they can charge all of this this markup here because they're a monopoly and they have that market power. And so this box here is their profit. So they produce a quantity here and they charge price R. And that's the profit maximization decisions. That's the optimal quantities to produce. And then the next class, so in conclusion, like I said, short, all firms choose the optimal quantity to maximize profit. And this optimal quantity is where marginal revenue equals marginal cost. Only difference from monopolists from perfect competition is that the marginal revenue curve does not equal the demand curve, because they are all of the supply in the market. And so next class, we'll dive into more of the ramifications of monopoly. And then after that, we'll get into how firms try to behave like their own little monopolist, even when there are a lot of other similar firms in the market, and why that's good for them. And so that's it. And thanks. I will see you when I record week 13, day 2.